Experimental errors. Let's define an error. What is an error? Take down, please. Error. Definition. Errors are uncertainties in the value of measured or given parameters. Errors are uncertainties in the value of measured or given parameters. Types of errors. Types of errors. Types of errors. Number one, systematic errors. Types of errors. Number one, systematic errors. These are uncertainties. These are uncertainties in the measurement of physical quantities. These are uncertainties in the measurement of physical quantities due to instrument error, fault in the surrounding, due to, number one is instrument error, faults in the surrounding conditions, faults in the surrounding conditions, faults in the surrounding conditions, or mistake by the observer, or mistake by the observer, or mistake by the observer. Full stop. Some examples of systematic error include number one, zero error. Some examples of systematic error includes number one, or either zero error. So zero error is a type of systematic error. When we say zero error, what do we mean? Zero error occurs, let's explain a bit, occurs if the reading of an instrument should I close it? Chief, don't stay there, don't stay there, don't stay there. Please, turn there. Alright, zero error, I said, occurs if the reading of an instrument occurs if the reading of an instrument is not zero. Occurs if the reading of an instrument is not zero, even when it is not in use. If the reading of an instrument is not zero, even when it is not in use. Example, a stopwatch. Example, a stopwatch does not point at zero. Example, a stopwatch does not point at zero but 0.1 second. Example, a stopwatch does not point at zero but 0.1 second. Now look up, please. Let me explain what a zero error is. Now, zero error is usually an instrumentation error. For zero error, let's say I'm doing a simple pendulum experiment where you expect that the pendulum bob should be going 1, 2, 3, 4, and they'll ask you to measure the reaction time, or they'll say after 10 oscillations, how long do you take? So immediately you push the pendulum bob, it goes 1, so you start your stopwatch. in some cases, for some stopwatch, you observe that I'm expecting that this hand should be at 0 before I start using it. But you observe that in some cases there, the stopwatch is not really at 0. The hand has deviated a bit. It's not in use, but it's pointing like this. At this point now, this stopwatch has already given you a like 0.1 seconds faster kind of reading. So this is called what there is zero error. So it occurs when the pointer, either in a stopwatch or in a beam balance also, when the hand is not in 0, this is what is called a zero error. Number 2, types of systematic error. Number 2, personal error. Number 2, personal error. Number 2, personal error. What's personal error? Take down, please. Number 2, personal error. These are errors due to the limitation of an individual. Errors due to the limitation of an individual. Due to the limitation of an individual. Example, reaction time. The limitation of an individual. Example, reaction time. Let me explain what reaction time means. I'm not trying to be anti-feminine now, but I think this one here is most common with the ladies than with the guys, from my own observation. Let me give you what I mean. So a simple pendulum experiment, you're asked to calculate the time or find the time it takes for the pendulum to go 10 oscillations. So are we ready? Group practical, of course. Are we ready? Yes, sir. Let's go. So 1 to go. So you swing and you start. Start. So it goes 1, you're checking your time, 2, 3, 4, 5, 6, 7, 8, 9, 10. Stop. Before you stop, that's gone 11 and 12. At that point, then there's an error there. The error is because of what there? The individual there. You're supposed to stop the stopwatch at exactly what there? 10 oscillation. But before you even realize that it's 10, it has already gone 11 and 12. At that point, you have an error there. That's called what there? Error due to reaction time. And that's the idea of personal error. So that's it. The last type of systematic error is called error due to wrong assumption. 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 What does it mean? Take that, please. I want to believe that the definition is clear enough. All right, when you assume wrongly. So I'll just give an example. Example for this. Example, assuming gravity G to be equal to 10 meter per second squared instead of 9.78 meter per second squared. The value of gravity is up for your own debate. Some will say it's 9.81, some will say 9.8. This one now is saying 9.78. But the idea is this: gravity is not necessarily 10. Please. So if I now take G to be equal to 10 instead of its original value, it's called error due to assumption, and it's under systematic error. So under systematic error, we have 3 types. Number 1, zero error. That occurs if the pointer on your measuring instrument like stopwatch or beam balance is not at 0. Number 2, personal error due to reaction time. Number 3, wrong assumption, which I've explained. That reminds me, I said in your physics practical, expect more of subjective. In some cases, they are usually objectives, but it's very rare, probably 2 or 3 questions, but majorly is subjective. Now, this is how they set the question. They will ask something like this. They'll say, They'll ask a question like they say, a boy measures the length, a boy measures the length of a staircase as 7.23 meters, but approximated to the nearest whole number as 7.00 meters. Listen up. A boy measures the length of a staircase as 7.2 meters, but approximated it as 7.00. What kind of error is that? So number one, systematic. Number two, personal. Number three, or B, C, they will say zero error. D, they will say error due to assumption. Which should it be? Huh? A boy measures a staircase as 3.72, but then he was trying to use to the nearest whole number, so he assumed it to be 7.00. What kind of error is it? Is it systematic? Is it zero? Is it personal? Is it assumption? Which of them? Is it systematic? Please, please. It is systematic. Hold on. It's systematic in the broad sense. But if you now have systematic and assumption, please go with assumption. Please. Yes, it's under systematic. But the thing is this, under systematic, there are different types of error. So in this case, you use what there? The most correct, which is what there? Assumption. So it's not systematic. Why systematic is a likely answer, it is not the most appropriate answer. It becomes assumption instead. So I say it's kind of tricky. So please, it's assumption, not systematic. All right. Types of error. Number one, we said systematic error. Under systematic, we explained three. The second type of error is called random errors. All right, let's look at a second type of error called random errors. Take that, please. Whenever it's an error, your first definition should be it is an uncertainty in measurement. Uncertainty in measurement. Let's define random errors, please. Take down. Random errors are uncertainties in a measurement. They are uncertainties in a measurement which are mostly irregular. Uncertainties in a measurement which are mostly irregular, errors arising from a number of factors. They are mostly irregular errors arising from a number of factors. Full stop. The characteristic of random error is that it can be positive or negative. The characteristic of random error is that it can be positive or negative. And its magnitude is not constant. And its magnitude is not constant. Examples of random error. Examples of random error. Number one is error of judgment. Number one is error of judgment in estimating scales Number one is error of judgment in estimating skills, which varies for individuals. Example, parallax error. They'll say parallax error is an example of dash error. The answer is random error. A second type of random error, number two, fluctuating conditions in temperature, pressure, voltage, etc. All right. So we have number three, inhomogeneity of materials measured. I'll explain this one, parallax error. When we start doing this, what's it called? Your graph. I'll explain this better. Examples of random error. Number one, parallax error. Number two is fluctuations in surrounding conditions. For instance, I'm doing a simple pendulum experiment. Right now, the fans are off because there's no light. So I'm doing a simple pendulum experiment. I start swinging my pendulum bob. Immediately I swing it, it goes 1, 2, 3. And along the way now, they now give light. And then the fan starts blowing there. Of course, you expect that this fan here will affect the motion of what there? The pendulum bob. So at that point now, it will not swing in its normal state. So hence, there will be what there? An error. That error is called what there? A random error. Why? Because of what? Fluctuating conditions in temperature, etc. I'm doing an error for Ohm's law. Of course, Ohm's law, we know that V is equal to IR. You're doing this experiment there. And I'm expecting a certain current value. But then, when you're working with the ammeter, there was a fluctuation in the current supply. And due to the fluctuation in the current supply now, I was experiencing an error in my Hooke's law, in my Ohm's law experiment. That's an example of what there? Random error. Number three, I'm measuring, let's say, a particular body that is irregular. Example, a stone. When we say a material is irregular, what does it mean? When a material is irregular, what does it mean? The what? Yeah, the shape is not definite. You can't really measure the length. It's not very definite. So I'm measuring, let's say, the dimension of a stone. And somehow, when I did my first measurement, I had a certain value. I measured again after some time. I still had a certain value. They were close, but not the same thing. There's an error there. That's called what there? A random error. All right, so that's stuff there. The third type of error, there are three types of error at your level. The first one is systematic. The second one is random. The third one is called erratic error. Number three, erratic error, please. Look at erratic error, and that's about it. Erratic error, please. This is more of a mistake. Erratic error. This is more of a mistake. This is more of a mistake For example, arising from, this is more of a mistake. Example, arising from arithmetic, comma, from arithmetic, comma, miscounting a number of periods, comma, faulty electrical contacts, faulty electrical contacts, and wrong scale reading, and wrong scale reading, and wrong scale reading. Full stop. Full stop. A little more care, continue. A little more care and practice. A little more care and practice. A little more care and practice may enable students not to commit erratic error. A little more care and practice may enable the students not to commit erratic error. All right, let me give you a sample something there. All right, so look up, please. Look up, please. They could give you a table like this. A table like this will say the period of oscillation for a simple pendulum is given in T seconds. The period of oscillation of a simple pendulum is given by T seconds, while the number of oscillation is given as X. The period of oscillation, you can say, as measured by students, is given by T seconds, and the number of oscillation is given as X. 25, please. Is given as X. As shown in the table below, they'll give you this table here. They will say, what kind of error do you observe here, and what step can you take to avert the error? Number 7. From the table below, you have this. The period of oscillation is given by T seconds, that's this. And the number of oscillations is given by X, that's this. They will say from the table there, what kind of error do you observe, and how can you avert the error? What do you think? What of error is here? Erratic error. Erratic error. How? Why? Observe there's a miscounting. 1, 2, I expect what there? 3 next, not 4. It's an oversight. It's a miscounting. So miscounting becomes what there? An erratic error. That's it. So it's a miscounting. You have to open your eyes very well. It's a miscounting. So the guy is counting 1 second, 2 seconds. You expect 3 seconds next, but you're saying 4. So he has omitted, he has miscounted 3. and it's gone to 4. So it becomes a miscounting. They ask you what kind of error is that. You do what there? Erratic error. Please, don't just write miscounting. Miscounting is not an error per se. It's an example. So if I were you, I'd write erratic error in brackets, miscounting. Close the bracket. Then I asked you, they said, what steps can you take to avoid the error? What do you say? Huh? What? A little more there. Carefulness and what there? Practice. Check your note now. Is there? Is there? We said a little more care and practice. So that's your answer. The idea is care and practice. That's your answer, please. All right. I think that's this for this. All right. I think that's this for this. This is part B. Part A is graphing, graphical, whatever we're done. Part B is error analysis. Please, we'll still touch these ones later. I'm just giving you a basic concept before we look at something else. Part C, accuracy and precision. Part C, accuracy and precision. So before we go to accuracy and precision, expect things of this nature. They'll say you're given a table below, which is this man here. They'll say what kind of error do you observe in this table? What kind of error do you observe in this table and why? What kind of error do you observe there and why? And what will be the solution to it? What kind of error do you observe in this table? First of all, is there an error? Yes or no? What's the error? Huh? I'm having 6.25 here. This is mass in kilogram. This is m over 2. 7 over 2, 3.5. That's correct. 13 over 2 becomes what there? 6.5, not 6.25. So observe that this value is correct, 3.5. Divide 15 by 2, 7.5 is correct. Divide 17 by 2, 8.5. That's correct. 19 by 2, 9.5. That's correct. But this one here is wrong. So I'm having this here. They're asking you, is there an error? Yes. What kind of error is this? It's erratic error. How do you correct it? Being careful, more practice. Being careful, more practice. That day you see erratic error, you will not know to happen. You just don't know. This one says, the following table was made by a student. So you have this. A says, what is the major error in the table above? A, what's the major error in the table above? B says, is the error random or is it systematic or is it erratic? So it says any other error. All right. A says, what is the major error in the table above? That's your A question. B says, the error there, is it random? Is it systematic or is it erratic? C says, is there any other fault you can detect from the table? So let's talk. Let's talk, please. A, what's the major error? What's the major error? Huh? What's the major error? Yes, what's the major error? Erratic is not, no. B says it random, systematic, or erratic. Know how to answer question. It can't be erratic. If A is erratic, B will not be what there? Double erratic. And C will not be what? Triple erratic. Look at this table. They say number 1, what is the major error in this table? What's your answer? Huh? Standard. What's the major error now? Arithmetic error. How do you reconcile the table? All right. So here's what's up. If I were you, what I'll do is this. Look at the table I'm giving R. Its value being 1, 2, 3, 4, 5. Settle. Next up, 1 over R. 1 over R becomes 1 over 1. That's equal to 1, not 0.1. 1 over 2, that's 0.5, not 0.05. 1 over 3, that's about 0.33333, not 0.033, no. 1 over 4, that's about 0.25, not 0.025. 1 over 5, that's about 0.2, not this. So the question is, what is the major error? The answer is simple. The major error is that the values of 1 over r are incorrect. That's it. Not arithmetic. It's arithmetic what? So your answer is values of 1 over r are incorrect. Or you can say incorrect values of 1 over r. I'm going to tell you what is the error arithmetic. You think it now. What is the error arithmetic? How? B says, is it random? Is it systematic? Or is it erratic? If you're here before, we know that it's erratic error. That's why it's erratic error. C says, is there another error you can find from the table? Is there another error you can find from the table? No. If you say yes, what is the whatever? Sorry? Should be serious, so. Be serious, so. What else can you find here? What other error? What other possible error can you find here? Well, if I look at this, what other error can I find? Number one, I said whenever you're doing something of this nature, we expect that all your values should be in uniform decimal places. This one cannot be in a decimal place, and this one in 2 decimal places, and this one in 3. No. So number one, non-uniformity of decimal places for the values of 1 over r. Also, can we also spot another error? Possibly. Can we also spot another error? Yes. What's the error? Alright, next time it was recorded. So assume R to be resistance. That should be in ohm. Very important. So you put your unit there. And this one becomes per ohm. That's ohm to power minus 1 per ohm. So these are like the 2 errors I can find here. So that's how you answer this question. So see how this is. It's not hard, but then you have to think. Alright, so that's how we get this question done.